Hello CIS 1400 and welcome back. Hopefully you had a chance to read the text and watch the previous video on functions. In this video we're going to keep it probably pretty quick. We're going to talk about some common string functions and things you can do with strings. I'm not going to focus on pseudocode or flowcharts here. Most of this is just going to take place in Python to talk about how we can use these functions and to help us out with some of our text processing that we'll have to do in upcoming labs and modules. So strings are an interesting data type. There are lots of things that you can do with them. Listed up here on the screen are a couple of those things. There are many more. You can also click on that common string methods or just Google the string class in Python and you can see all the different functions that you can do with them. So here's a few of those functions that you can apply to a string to do certain things with it. To use these functions, it's going to be a little bit different than the functions we've written in the previous lesson. So follow along and I'll show you how to use everything that you need to use in order to get the exact output that you're looking to get. So some common string functions are listed right here. We've got upper, lower, swap case, capitalize, title, strip, and replace. To be perfectly honest with you, the three that you'll probably use the most are upper, lower, and strip. Okay. Upper will take whatever string you're using and return a complete capitalized uppercase version of that string. So any lowercase letters will get converted to uppercase letters and all the uppercase letters will stay the same. Lower will do the exact opposite of that. Lower will take all of the uppercase letters and change them to lowercase for you and return a string in all lowers. Swap case will return a new string in which every letter is switched case, so all the uppercase will become lowercase, lowercase will become uppercase. I haven't found much use for that, to be perfectly honest with you, but it is available. Capitalize is interesting, where it returns a new string where only the first letter is capitalized and all the rest are lowercase. Useful if you know it's going to be short, you want that first letter capitalized every time. Title might be more appropriate where it returns a new string where the first letter of each word is capitalized and all others are lowercase. But strip, to be perfectly honest with you, is a very useful one. This returns a string where all the white spaces at the beginning and the end of the string are removed. So any tab spaces or new line characters that may be embedded in there, it'll take them out so that you can process it. You'll use that one a lot in sort of form processing, so that when somebody's typing in, say, like an email address or maybe a password or something, and those spaces aren't really valid characters, but they actually type them anyways, you can take that out for the user so that you don't have to tell them that it's an invalid password or username or whatever it may be, simply because there's white space in the front or behind the characters that they see on the screen, because white space is very hard to see when you're typing. Replace is a useful function where you can pass in 2 and up to 3 arguments, where you search for an old string that you'd like to replace with the new string, and the third and optional argument is the upper limit for how many replacements get made. So if you type in like a 3 there, it'll only replace it 3 times, a 5 times, so on and so forth. So I'm going to switch over to something real quick and just kind of show you how these methods get used. So I'm actually going to run back into idle here, just because it's quick and simple to kind of show you and execute, and we'll run a program where we can kind of see these things getting used in all their glory anyway. So first thing is I'm going to come up with a string. Maybe I'll just call it my name, okay, and my name is, as a string, well, let's do this correctly, name equals Brandon John. Let's spell it like this, John. Okay, so there's my, oh, come on, forgot the quote. Let's try this again. Enter and quote, and there it is. Okay, so now I finally have a variable saved. Took long enough, but got it. So now what I can do to this is I have a variable that has a string in it, and so now I can use those functions from the previous slide, like upper, lower, swap case, capitalize, title, strip, upon it. And so anytime we're using those types of functions, we call them object functions. So they need something to be called from. We don't just blatantly call them and say an assignment statement or something like that. So I might say something like name dot upper. And I'll still have those parentheses at the end, but you notice that when I press enter, it actually returns a new string, okay, that has all the characters in my name completely capitalized. And I can do the same thing, name dot lower. And there it is, all in lowercase. Now, obviously, if I go back to name and print the name, it hasn't really changed because I never made any kind of assignment statement. I never changed anything, but this is idle. I'm just trying to show you what these functions are doing and what they're returning. So every time it's actually printing something out, it's just showing you basically what this returns, okay? So I can do something like name dot title, right? And you'll see that it capitalizes the first letter of each word. I could do name dot capitalize, and now it lowercases every word or every letter except for the very, very first one. I could use the strip function. You won't notice much here, but let's come up with a new word, and we'll say word equals hello, and there it is. Okay, so that one has a lot of white space in it. Obviously, if I print out word, it's going to print kind of awkwardly. But what I could do is word.strip, and now it takes all that white space before and after it and trims it off. So now I have just the word that I want as I go through. Okay. We forgot swap case, so let's go back to name.swapCase. And there it is. All of the uppercase letters went to lowers, all the lowers went to uppers, so it looks kind of awkward, but it does what it was supposed to do. And I could use the replace function like name.replace, and I want to replace the string John. Let's make sure we spell it right the way that it was spelled in there, John, with John. I'll spell it like that instead. And that's all I want. And so when I do that, now it replaces it appropriately. Okay, so those are the string methods that you can use. They're all pretty simple to use. We'll do this a lot when we have some sort of like input that we want to get. We want to make sure it's formatted appropriately. So for instance, let's say I want to get somebody's, let's say just somebody's name. Might as well be somebody's name, but I want it formatted in a very particular way. I wanted to make sure no matter how they type it, okay, it always comes out in this case, okay, where it's always titled, okay. Everything is always capitalized for the very first letter. So maybe I do something like this. I want to say name equals input, enter your name. Right? And now I can get it, and I'll type in my name. And I'm typing it goofy on purpose so that I can make sure that whatever I type in, it won't make a difference. I can then do something with it. I could say like name equals whatever the name is dot title. And now what's stored in name is the perfect version of that name. Now even that was a bit laborious. I could actually shorten this up a little bit. I could do something like name equals input, enter your name. And even right from here, since I know the input function is going to return something of type string, before I make the assignments into the variable called name, I can right away just go dot title and format it appropriately. So I know from the input function it's going to grab something, it's going to give me a string, and since I know it's going to give me a string, I can apply this function to it, and before it even stores it in the name, I then have it appropriately. So I can enter it again, all goofy like. Right? And I press enter here, and then when I actually print out the name, it's perfect. So again, this is great use of stuff when you are collecting information from a user. And you know that user information is going to go into a database somewhere or into some sort of form or spreadsheet, whatever it may be, and that data needs to be formatted in a very particular way for searching and sorting purposes. So instead of relying on the user to type things correctly and giving them a bunch of error messages when they don't type certain things in the format that you want, why not just change it so that it's in the perfect format for them so that they don't have to worry about it? You are absolutely positive that you're getting the data in that you need to get in. So these are just a couple of the functions that we can use to make sure that that works pretty well. So upper, lower, swap case, capitalize, title, strip, replace. Like I said, most of the time you'll use things like upper and lower to make sure everything's in the same case. That way you can check against things very, very easily. Sometimes title or capitalize. Lots of times strip to get rid of that white space before or after so that you can eliminate that out of the problem areas. But those are some of your common string methods that you can use. Okay. Now, strings are sequences in Python, actually, and all sequences come with information that you can pull from them. One of those things is that you can identify how big a sequence is by using a built-in Python function called len, stands for the length. What you would pass to it is then the sequence that you'd like to know has how many elements. So let's kind of demo that real quick. We'll come over to idle. Let's make a program. Okay. So we'll come over here. We'll go new Python. Oh, not Jupyter file. Get out of that. Over here we'll go new Python file, and we'll do string work. Okay. So let's come over here, and I want to file because I want to be able to store it and manipulate it and run some things. So let's come over here and we're just going to write a quick script that might get us a quick string. So we'll call it str equals input, right? And we'll say enter a short phrase, right? And we'll grab that. And what I want to do is just print, say, the length of it. So we'll find out how many characters it has. Now before, we had to go through a whole looping activity to kind of figure this out, but it's actually really simple. I can just type len of str, and it will figure it out for me. So now I can print and say str has num characters. So again, let me come through and we'll just kind of play this real fast. Run string work. I can enter a short phrase like hello world. And there it goes. It says hello world has 11 characters, in which case it does. There are 5 characters in the word hello. 1, 2, 3, 4, 5. There are 5 characters in the word world. This space counts as another character. So if you wanted to eliminate that space, you'd have to find ways of filtering it out, replacing it with something else or with nothing, whatever it may be. But there are ways of going about it. So you can enter a short phrase and work your way through. Okay, so the len function is actually pretty useful and allows you to kind of see that how big a certain sequence is. Okay. Python's in operator is a really nice Boolean operator that you can use on sequences, strings specifically, to see if a certain item is a member of the sequence. So let's say we've got this phrase and it prints out how many characters, and what I want to do is figure out if an L is simply in the phrase. So I can say something like this: if an L is in str, print that the str has the letter L. Okay. Otherwise, we might print that it doesn't have the letter L. Okay. So let's go ahead, run it. I type in hello world. It says hello world has 11 characters. Hello world has the letter L in it. Okay, let's say I ran it again, but I ran something without the letter L in it. Okay, so I enter a short phrase, something like this is amazing. This is amazing has 15 characters, but notice it never printed anything because this function was not true. I could have easily made an else here that would also state that this does not have the letter L in it. So let's just copy that, paste. So let's try it one more time. Amazing has 7 characters, and it does not have the letter L in it. So anytime you want to check to see if an element is a member of a given sequence, it's actually pretty easy to do. You just have to use that in operator, and that's what we were using with the range function anyways. The range function produced a sequence, and we were trying to see if I was a member of that sequence. Well, since I was taking on all sorts of different values, yes, it was a member of the sequence, so it actually worked out pretty well for us. Okay? Now, the nice thing that we can also do is that sequences are indexed. So we can check to see where a certain value is or what a certain value is at a particular location in a given sequence. So if I had a sequence that was called Python, Python, this string is 6 characters long, 1, 2, 3, 4, 5, 6, but it can be indexed from 0 through 5. Okay, so 0 being index 0 being the letter P, index 1 being the letter Y, 2 being T, 3 being H, 4 being O, 5 being N. Okay, so what I can do, let's come back over here. Okay. And start thinking about how we can index this and work our way through it. So I'm going to copy or kind of comment some of this stuff out. And actually, I'm going to go back over to idle. It'll be quicker over here. So let's see what we can do here. Let's make a string here at the bottom, and we'll go str equals Python. Okay. And what I can do is I can say str at index 1. And what it does is it produces the item at index 1. Indices are always 0 based, so the very first element of any sequence is always at index 0. Therefore, the second element is always at index 1. So y would be the second element. If I did str of, say, 5, right, it's going to give me the end. Now, anytime you're indexing something, you have to name the sequence that you're trying to index, follow it up with a set of square brackets. Okay, right next to the piece key. The square brackets will tell you that you're trying to pick out a particular member of the sequence. When I put in a single integer there, that'll tell me that I want that one chunk. Okay, let's come up with a new sequence, maybe something like name equals Brandon. Okay, and I say name at 3. Well, what do you think that's going to produce? B is the 0. R is the 1, A is the 2, N is at index 3, and that's what it can give me. Now the trick though is you always have to make sure you're using indices that are valid. So if I try to do something at index 8, well, it's not going to like that because there is no index 8 in this string. Since there are only 7 characters in my name, index 8 is 2 past what it can be. The last index here is 6. So I can't really actually use index 8. So I have to make sure that I stay 1 under the length of the string. So if you ever want to get the very last character in a string, it's pretty easy. You go len of name minus 1. That will allow you to figure out how big it is. Take 1 away. That'll put you at the final index. And there you go. You get the last piece. Now, Python prides itself on making things simple. Okay, most programming languages don't do this, as far as I know. But Python actually allows you to index things in reverse order as well, so by negatives. So again, like I said, if you want to get the last character, you actually can always just type in a -1 here, and it will produce the last character. If I do name of, say, -3. Okay, what that'll do is count 3 from the back. So -1, -2, -3. Since 0 has to be the first value, we can't have 0 on both sides. It doesn't make any sense. So 0, if we're using positive indices, starts on the left. If we're using negative indices, -1 is always the last character on the right, and then we can work our way back. So -3 produces the D, -1, -2, -3. Okay? Not entirely useful, to be perfectly honest with you. I'd say of all of them, this particular syntax is the most useful when you're trying to find the end of the string or maybe the last character of a sequence. That's an easy way to do it. Most programming languages that I've run into will have you do some syntax more like this, and they don't index things negatively, although some are starting to come around and become more intuitive, much like Python is kind of set up to be. So keep that in mind for future reference. One other thing that you can do with strings, not only manipulate them through functions and access individual elements, you can actually access chunks of the string. It's a process called slicing, okay, or creating a substring. So if I did something like name bracket 1:3, what that's asking me to do is to grab all the letters from index 1 up to, but not including, index 3. So when I return this, it actually produces the R and the A. The R is at index 1, the A is at index 2. I don't use index 3. So if I want some chunk of this, I can say name bracket 0 through 5. And that'll produce the first 5 characters of my name. Index 0, index 1, index 2, index 3, index 4. And there's your entire substring, or your what we call a slice of a string. Okay? Slicing can be done pretty easily as well. If you need to start at the beginning, you actually don't need to provide it with a 0. Let's say I just do name bracket, and I want up to 3. Without providing that first element, it'll always start at 0. I can also slice from an element all the way to the end. Name bracket something like 2 all the way to the end. Just close the bracket, and it will start at index 2 and give me everything to the end. So A is at index 2 all the way through. So it's a nice, easy way to kind of get chunks of the string, right? And it can be quite useful for making sure that you have a certain portion of the element as you're going through. Right? So let's do a couple problems just to kind of get the gist of everything that's going on. Some of these problems will probably look familiar as to the last lab that you just did. So we want to design a program that'll prompt the user to enter a string and display the contents of it backwards. For instance, if the user enters gravity, it'll produce YTIVARG. Okay, so let's try that one first. So I'm going to come over to PyCharm. Let's go with a couple string functions that we want to make. Okay. And let's think about this. We want to create a function that will give us the string in reverse order. Okay, so let's come up with a function. So def get reverse. Okay. In this function, we're going to pass in an original word or phrase. Okay. We'll call it original word. And our goal is to produce a reverse word. Okay. So how are we going to do that? Well, we have to build the string for all the characters in reverse order, which means we need to access all the members of the string and start to populate it. So in this particular instance, we can use it without using any of the new techniques. To be perfectly honest with you, we'll do it kind of like what I would have expected you to do in your last lab, but in a function notation. So maybe we'll come up with a reverse word and make it equal to an empty set of quotes so that we can build on it. We'll loop through all of the characters of the sequence. So a for loop does that very well. For character in original word. And what I want to do is add all those characters to reverse word, but I want to do it in the right order. So I want to take it and I want to keep, since I'm grabbing the first character, I want to make sure that that ends up, that first character, at the end of the list each time. So I want to take my reverse word and make it equal to the new character plus whatever was once in reverse word. And let's return the rev word. Okay. So let's real quick make a main method that'll call this def main. We'll gather some input, and we'll do a word equals input, enter a word, and then we'll call this function and print it out. So we'll just simply print the reverse of word is, and then we'll do get reverse of word. So let's try it out. Let's call the function, see what happens. If name is main, we'll call the main. And let's see if we did this right. So put it together, debug it. No, we don't want to debug. We actually want to run it. Oh, looks like it's running. Okay, so we'll enter a word. We'll enter gravity. And there it is. Let's enter another word. Race car. And it produced race car. Probably not a good word to use the first time since race car is a palindrome. Okay, so there's another quick and easy way to check to see if something is a palindrome. We could build this function and then call this function to kind of help us out. So maybe we do that real quick just one time. We do something like is, or def is palindrome. And I type in a word. And now since I have this function that'll reverse it for me, it's pretty easy to do. All I need to do is return whether or not the word itself is equal to the get reverse of word. That's a pretty simple way of going about it, isn't it? Okay, so now I can check to see if the word is a palindrome. So all I have to do is do a little condition here that might say if is palindrome of word. I might want to say yes, it is a palindrome. Print. Oops. What do I want? Comma. Otherwise, else, print. And I think I've been spelling palindrome wrong the whole time, so we'll just add that E on there. Help us out. Oops. We'll add it in right here too. Okay. So let's see how that works. Let's type in a word that we know is obviously not a palindrome. Gravity. Not a palindrome. Let's try it again. Let's enter a word like race car. Is a palindrome. Now I want to try it one more time. I want to do this. I want to type in race car one more time, but I want to type it like this. Now, real quick, what do you think? Palindrome or not a palindrome? Make your guess. I'm going to press enter in 3, 2, 1. Not a palindrome. Why not? Well, because it's building the string and it's putting it in reverse order. But since my string has characters of different cases, it can't really tell if it's a palindrome because it's checking it character for character. And the word race car forward and backwards in this case is spelled a little bit differently. They're not identical. So what can we do? Well, if we're really going for this whole is palindrome piece, okay, what I could do, since words are strings, I could change them and manipulate them to all of their lowercase versions or uppercase versions just simply for the palindrome part. So I can say if return word dot upper and say get reverse of dot word dot upper. Word is a string. I can apply this function to a string. This function returns a string, so I can apply this function to it as well. So let's try it one more time using race car spelled in that awkward way. And there we go. Now we've got a palindrome. So I'm able to use those functions that I mentioned a little bit before in a meaningful way to help me solve a problem that the user may not understand exists. Race car is a palindrome. It should be told it's a palindrome the entire time. Well, why wouldn't it? Because we didn't type it right? That doesn't make a whole lot of sense, and it wouldn't make much sense to the user. So find a way to make it foolproof, and this is one of those ways. All right? So hopefully that kind of helps with that. Let's do another one. Design a program that prompts the user to enter a string. The program should then display the number of vowels and the number of consonants in the string. Okay, let's make a function for it. Let's come down here. We'll do something like this. We'll go def num vowels. And obviously we'll need to type in a word. Right? And what we want to do is kind of loop through the word and all the characters in the word, and we want to check to see if they're a vowel or not. And if they are, keep track of how many there might be. So let's try this. Let's go with num vowels. We'll say counter equals 0, right? For character in word. And if the char, okay, is a vowel, well, how am I going to determine if something's a vowel? Well, char could be an A, or it can be an I, or it can be a U, or it can be an O, maybe a Y. We won't count Ys, but you get the idea. That's a lot of stuff to check, and I can write a lot of if statements. But if you remember this in operator, if char in, and I can write a sequence of nothing but vowels, A, E, I, O, U. Well, if the character that I picked out happens to be in this sequence somewhere, it has to be a vowel. So what I can do is increase counter. And when this is all said and done, I want to return the counter so I can use it. Okay, so that's not bad. Let's maybe make another function that'll return the number of consonants in the problem, okay, or whatever it may be. So we can go something like this, or it'll just display the number of vowels and consonants, okay? So we'll make a module that will call this function. Display characters, okay? We'll pass in the word to make this work. So first thing we might want to do is come up with a total length, right? Number of characters. Well, that's equal to the length of word, right? And then now I can come up with the number of vowels. We'll call it number of... I hate making variable names the same as function names. It just doesn't look right. Equals, we'll say num vowels of, number of vowels, num vowels of word. And if we want the number of consonants, all we really have to do is take the number of characters and subtract off the number of vowels, right? That would tell me how many consonants there are. And then I can display all this information. Print vowels. Vowels in word. And we'll say num vowels, number of vowels. And we'll say print consonants. I have no idea how to spell this. Consonants whatever, in Word, we'll say numcons. Okay, and I missed a comma here, so we'll put that back in. And let's go ahead and call this. Okay, so we'll still get the same input, so we'll enter a word, and then we'll just simply call display characters. Right? So I'll run it, we'll see what happens. So we'll type in a word or a phrase. We'll type in something like hello again. And we are missing a positional argument. Oh, we forgot to type that in. So if you ever get this, it's where it says it's missing an argument. It's because we forgot to put an argument that we were expecting in the function. The function's expecting something. We need to make sure we put it in. We're going to put the word in. All right? So let's try that again. Let's zoom in on this. We'll type the word hello. And that should come up with... Oh, I want hello W. So 2 vowels, E and O, and 4 consonants. So 4, H, L, L, and W. For whatever reason, I typed W. But there you go. It's starting to work. So now I've got this ability to work with everything. I can come up with a function that produces the number of vowels. The number of vowels come out with that in operator being used rather effectively to pick out a single character from word to see if it's a member of this sequence, this vowel sequence. And then I've got a module, just a regular old module, not a function here, that will utilize that num_vowels function to help me kind of build what it's meant to do. So now you're starting to see how it all kind of flows together. Okay. Let's try the last one. Design a program that has to use a string containing a series of single-digit numbers with nothing separating them. The program should then display the sum of all the digits in the string. So let's do this. We'll call it def sum digits. Okay, and we'll pass in some sort of value. Okay, so we're actually going to pass in a number. What we'd like to do is turn it into a string and add up all the numbers to it. So whether we pass in a string or not, let's see what happens. So let's say we pass in some sort of number. Okay, first thing I want to do is change the value to a string. So I'm going to say that this is called the S value for a stringed version of the value. And I'm going to say str of value. Okay, what that'll do is take my value, turn it into a string, and a string is really nice because it's a sequence of characters. Now I can loop over it for char in S value, and I can then revert it back to an integer for each individual character and add it to sum total, which we're going to need. Total equals 0. So let's go with that. We'll do total plus equals the integer version of whatever the character is. And let's return total. That's all said and done. So essentially what I did is if I'm passing in a value, an actual integer number, I can bring it into and make it a sequence by converting it to a string. I can loop over every character in that string, and each character is a single individual digit. It just happens to be in string form. I could change that character into an integer and increase total by it. So let's call it and see what happens. So instead of a word here, we're going to input a number, value int input, enter a number to sum digits of, and then what we'll do is we will print or come up with a total. We'll say a sum maybe equals sum digits of value, and then we'll print it. Total of all digits of value are sum. And let's see what happens. Got it? All right. Alright, so I'm going to enter a number, maybe something like 1, 2, 3. Okay, 1 plus 2 plus 3 should make 6, and that's what we get. 6 every time. So, a couple different ways of working with sequences and strings that I'm able to do. Hopefully it kind of clears up some of the issues you might have. And make things a little bit easier. In the next video, we'll talk about validation, how we can make sure that the information that's coming into our functions, either via input or whatever it may be, is the correct type of information and written in the correct way. So that'll be some conditional looping structures to work through. But for now, that's kind of the end of the video on strings. Hopefully that helps out, especially with some of the function work, with all the nice functions that we just wrote, and being able to use them in some creative ways. So we'll catch you in the next video. Again, if you have any questions, post those questions in the discussion forum for Module 5 for all to see. All right? Thank you.